Real-world problem solving with Halo's built-in tools. For me, that's such an exciting topic to be asked to cover, and I was lucky enough to be invited by Halo to present a session on it, both to customers and fellow partners at Halosphere this year. It was a 50-minute slot, and for what I wanted to talk about, it was barely enough time to scratch the surface. Now, if you weren't able to catch it live, don't worry. In this video, I'm going to walk through all the key ideas, the examples, and the takeaways from that session. Because the video is going to be a slightly different format, I'll probably skip through some of the slides and spend the time going a little bit deeper into how the solutions were built instead. So to give you an idea of what's coming up, we have a password reset process, which provides a flexible way of generating secure passwords, and they can be really easily communicated to the end users. We also have a room booking feature which integrates with the CMDB, and that helps the end users find rooms with equipment that meets their needs. And then finally, we have a disposals process which leverages the built-in reporting tool and the API to identify and process assets which are needing to be disposed of. Now, if none of those things float your boat, stick with it, because just consider the video a kind of technical demonstration of how you might apply some of these built-in tools to solve some problems in quite innovative ways. I'm going to kick things off by asking you a question just to give you something to think about while you're watching. And that is, which of your processes would you automate out of existence? So let's say nobody's going to disturb you for 10 days. You've got all the technical resources you need on call and all the pizza you could possibly want. Now, automate one process out of existence. Now, you probably feel that that's achievable. And the reason I ask that is because that's our reality. Unfortunately, it's not everybody's. But time pressures aside, as consultants and partners, we're given the luxury of all of those, the space, the tools, and the support just to make things better. And we get to do that every day, and that's one of the reasons why I love the job so much. Anyway, leave a comment, share what kind of problems you would like to solve, or even better, share what process you already have solved, just for other people to learn from. To give you a bit of context, the client in all three of these examples is a further education group. They're spread across numerous sites many miles apart, and I worked for a Russell Group university for around 7 years, so I'm no stranger to the challenges of supporting staff, students and academics, all with different expectations. But one of the first solutions we were asked to prioritise was their password reset process. Now, this is a somewhat surprising thing for us to get involved in, but for reasons that I won't go into, there was no possibility of implementing a fully self-service password reset system. Their previous ITSM tool was loosely involved in the existing password reset process, but when moving to Halo, they wanted to grab the opportunity for that process to be fully driven by the new tool. The solution we provided centered around a guided workflow for the analysts to follow. Just to give you a quick overview of the process, the verify identity stage prompts the analyst to provide the identity verification challenge. This is facilitated by deep linking from Halo to their in-house system. The URL to that page is generated based on the user type and the user ID. When they do that, Halo prompts the analyst to record whether or not the challenge was passed or failed. A failed challenge causes the ticket to be resolved straight away, and that data can be reported on for monitoring purposes. If the challenge is passed, the analyst is presented with a verbatim text password that is generated by Halo, along with an equivalent NATO alphabet representation of that same password. And the reason for that is so it can be easily communicated over the phone. While the password is being communicated, a PowerShell integration is triggered in the background, which feeds back to the analyst whether the reset was successful or whether it was rejected. I'll show you how this works in practice before we take a look behind the scenes. So a password reset request only needs the user details to be populated. Once the ticket is raised, the agent has the option to verify the identity. That is the only way to progress the ticket. When we click on that, the agent sees the verification link, and this is that deep link to the identity management solution that provides the confidential information for a user to validate their identity. Once they've provided the information, the result of that challenge can be recorded here. And as soon as that is recorded, Halo provides the secure password that it's generated and also the NATO alphabet equivalent of that password. Now, it's a really straightforward process on the surface, but there's quite a lot of clever stuff going on in the background to make this work. So I'll show you the recipe for that solution. We have a custom table, which I'll show you in a short while. This holds the characters that are valid for the passwords, their equivalent pronunciation and the character type. The character type is important because that allows the SQL lookup to identify what characters are being used in the password and make sure that enough of each character type is being used in that password. So the SQL lookup I've just mentioned, yeah, basically that just creates the password using a fairly straightforward SQL query, and it stores both the representation of each character and each character into two custom fields on the ticket. So yeah, custom fields, one for the verbatim password and one for the word-based representation that can be spoken. And both of those fields are cleared automatically. Obviously we have the ticket type that ties everything together. And we have that action which provides the identity verification link and collects the result. The workflow, which you saw a drawing of, that just makes all the action commands available and performs the integration actions based on the input that's provided on the action. Then, of course, you've got the PowerShell integration. So this just passes the password reset request to a PowerShell script, and that runs on an on-premise server, which uses Halo Integrator. And that's been specifically configured to check for PowerShell jobs every 10 seconds. And that uses a combination of task scheduler and a separate PowerShell script which repeats those queries every 10 seconds for a minute, and then the task scheduler, after a minute, it kicks in again and checks for every 10 seconds for the next minute. And that really just works around the limitation of task scheduler, which you're only allowed to repeat a job once a minute. And then, of course, the PowerShell script, this was already implemented as part of the previous process. We did have to make a few changes to it. But essentially all that does is it parses the parameters, validates the actions are allowed to be performed. There are some users that they're not allowed to reset passwords for, so it does reject some calls. The good news is that around 800 passwords have already been reset using that method since it was implemented, and it's working well. But although improvements to efficiency and security have already had an impact, in my opinion, there's still further improvements to be had. For security awareness, I feel it would be appropriate to flag up anomalies in failed verification challenges. I would like to reduce exposure to verification data, so build in the identity validation process into Halo. You know, have some mechanism for storing and presenting only the data that's necessary. Housekeeping as well. You saw earlier that we're clearing the password data down after a day. I would like to use the Halo API to clear that data much sooner than that. And also, finally, just remove the intermediary, provide the password directly to the end user through another channel, removing the need for the agents to be exposed to the password in the first place. I really like that functionality because traditionally SQL lookups have been used to surface data that already exists in Halo. And what we're doing is using it to generate new data that didn't previously exist. There are many other possibilities for that functionality as well that we haven't yet explored. Next up is the room booking solution, and this is more fun than it sounds. So the client needed a way to book exam rooms across multiple campuses, and they needed to identify rooms which had the right kit for the students taking the exams. It's a straightforward requirement, but it couldn't be achieved without having both a reliable list of sites, buildings and rooms and an accurate CMDB. The challenge really was that not that that data didn't exist, it did exist, but it just wasn't in a format that was accessible for the staff booking rooms. So we implemented a location first approach, and this was based on the client's preference for prioritizing the venue over the facilities. This isn't how we would have chosen to do it, but this is what they asked for, and I'll cover more of that in a moment. So we created a room booking request form, allowing navigation through the site, building and room hierarchy. That's all populated from a custom table which extends the out-of-the-box site functionality. Selecting a room would present the staff member with comprehensive information on the room's inventory, and that's all coming from the CMDB. Staff could add special requirements to the booking, including requesting IT specialists to attend the exam. When IT support was requested, the system would automatically create appointments in that specialist's calendar. So I'll take you through how that works in Halo. Of course, we've got to start by creating a new ticket for exam request. You can probably tell that this is a much more stripped back version of that form that was on the presentation, and this was just built for the purposes of the demo. But if we select a room from this hierarchical selector, we can see that once we select that room, the form gets populated with the items that are located in that room, and that's coming from the CMDB. Now, this works quite nicely, but it's far from ideal in my opinion. A better way of doing that would be to allow the users to select what equipment they needed and to have the rooms filtered by whether or not all that equipment was available in it. And in a few slides time I'll bring that up and show you. But for now, let's just look at the recipe for this particular solution. Of course, we've got the custom table, and that is linked to the site object, and that contains a list of all the buildings and rooms for every site record. I'll give you a view of that in a short moment. We've got custom fields added to the site business object, so that is just a table field which allows those building and room records to be linked with sites. More custom fields, that was added to the asset types field forms, and that allows the location of every asset to be pinned down to the exact room that it's stored in. And even more custom fields. We have custom fields on that form that allows the location to be selected, and we also have the placeholders for the equipment display. To populate those fields, we have a SQL lookup, and of course we have a ticket type and a workflow. Before I show you any of the actual configuration, I'm just going to move on to the next slide. So from a user experience perspective, I would prefer to have the facility first approach that allows the requester to specify what their requirements are and have the system just present the rooms that meet that criteria. It would be great to have additional filtering options just to find the ideal venue, and then also integration into timetabling systems. I'm going to show you my preferred user experience, that facilities first approach. And now this isn't what was deployed into their environment. This is just something that I put together for the purposes of the demo. If we move over to Halo again and just open up exam request version 2, we can see that we have the number of PCs that are required, whether or not a projector is needed, scanner, printer, again, this is all just set up for the demo. You could have whatever fields you like there. We have the locations field. It's been renamed suitable locations because it is filtered now. And if we drop that down, we can see the locations that are allowed to be booked for exams. Okay, if I was to start populating this form and say I need a room with a projector, that's going to apply that filter immediately to that form field. And we can see that there is only one room that does have a projector. If I choose scanner, actually that's got a projector and a scanner. If I was to start saying how many PCs we need, let's say we need one PC. Most rooms do have that. If we increase that to 2, we can see that that list is reducing somewhat and further reducing again. If we need a lot more PCs than that, we can see that the library is probably the room of the location of choice for that one of these 2 rooms here. So just to reiterate that, this data is being pulled directly from the CMDB. It's using the data that's being populated in the form. It's correlating that with workstations. So it's counting how many workstations are available in each room, whether or not that room also has a projector, scanner, printer, etc. And it's just using that in the query to determine what options are available down here. Let's take a look at how that looks from the configuration side. And I'm going to start with the custom table because that's where it all begins really. So we have the site buildings table. So we got site name, building ID, building name. This is all the facilities information that were provided. And we have a location string as well, and that's important for the hierarchical selector. So all of this information, the site name, building name, and room name is combined into one field, and that's what drives that drop down. From the site object, we have this room field, which is added to sites, and that's linked to that custom table, that site buildings table, to provide the option of linking those sites, those buildings to the sites. We can see that here. And similarly in the CMDB, so if we were to go to the workstations configuration item, we can see that we've got locations recorded against each asset, and that is linked to the custom table as well. And finally, we've got the custom field for the suitable location. So let's take a look at that. Okay, this is called Locations Meeting Equipment Requirements. It's a single select field with a tree drop down. And so yeah, we're just selecting the room ID and the location string for the display element. That builds the hierarchical picker. We're bringing it in from the custom table, and we're joining over to the device table, which is the asset database. We're using the information from the custom table and the ticket. We're grouping it by the room ID, so we're able to aggregate that data, so we're able to count how many PCs, for example. And then we have this having statement. So device type 1 to 8, that is a workstation. And we're really just working out whether or not the sum of PCs that are available is greater or equal to the value that's been set on that field. We've also got the condition that says if a projector is required, Then it checks whether or not there's a device type of 160 in that room, which is a projector, and same with scanner. We're just checking if the value is 1, then we're checking if the number of projectors is greater than 1 or not. Same with printers. So yeah, all that does is it limits the amount of data that's being allowed to be brought through into that picker. It's really straightforward. It's just one of those things that uses functionality that already exists, that just hasn't been used in that way before. Right, finally, the asset disposal process. And I really love this one because it brings together a few pieces of Halo functionality in a very surprising way. If you're reading the slide, you can see that the client already had an established disposal process, and that covered their WE obligations and their commitment to secure data destruction. It's complicated by the fact that their estate was spread over numerous sites that were very far apart, and their WE contractor required at least 50 items for every location that they visited. They wouldn't turn up if there were fewer than 50 items. The solution we came up with for this was first to create a report that drives the whole process. Now that report queries the CMDB for all assets that are in the pre-disposal state. Then it groups it by site, and there's also a criteria in there which prevents a site appearing if they have fewer than 50 items. So we use that report in a runbook, and we have a ticket that is generated from that runbook, and then that ticket has its own workflow that processes it. Now, in a bit more detail, the runbook executes that report using the API, and the contents of that report is returned in JSON. The runbook then processes each row that's been returned, and it creates a ticket for each site. What happens then is that the workflow takes over and executes another runbook. The runbook knows what site the ticket has been raised for, and it requeries the CMDB to find every asset that is associated with the site and in the pre-disposal state. When it retrieves that information, it adds a link to those assets onto that ticket. So every asset is linked to that ticket. While it's doing that, it starts to build up a HTML table in the description. So for every asset, it's building up a row of data in that table. And that table's used by the approvers. And it contains information like purchase date, location, make, model, price, depreciation information. Once that table has been completed, all of the assets have been added, the workflow then goes through the approval stage. As you can see on the screen, if it gets fully approved, an automation happens which contacts the WE contractor, sending them the collection details, and then that updates the asset statuses. It changes it from pre-disposal, and then the ticket can be closed when the disposal certificate is received. If there's any objections to specific assets being disposed of, the agent can review those comments and make adjustments to the ticket. They can unlink or relink assets before it gets sent for approval again. Let me demo that to you, and then I'll show you behind the scenes. I'll start with a report because that's the foundation of the whole process. So we have count of pre-disposal assets grouped by site. I'll give you a quick preview of the query that we're using there, but it is fairly straightforward. We're searching for specific statuses. We could simplify this by not joining to the status table and just have the status ID, but this makes it a little bit more flexible for the client. They can update this with a different status just by typing the status name rather than having to know about the IDs. And you can see we're grouping by site. Sorry, we're joining onto the site and the status, and then we're grouping by the sites. For the purposes of the demo, I've reduced the threshold to 10 but in production that's set to 50. I'm going to show you quickly how that looks to the agents, but because this is all triggered by a scheduled runbook, I'm going to have to poke it from Postman just to trigger that manually. So I'm going to hit go on another screen, and then we should get a notification up here very shortly. There we go, just to confirm that we've had a ticket raised. It's already linked all of those assets, which is great. And if we go to the additional fields tab, we should see that that table is being built as we watch it. So we can see we've got all of those pieces of data. Again, some of them are blank because it is a demo system. But once all of those assets have been linked and the table has been created, the approval process triggers automatically. Okay, so we'll look at the integration runbook. So the first one that runs is the check for disposable assets. The first action that takes place in this runbook is to execute the report. And we do that through the report API method. And we're passing through the ID of that report, and we're saying that we want to retrieve the output from that report rather than just the definition of it. The API responds with the report rows. So we extract those and we store that in an array. And then we start to process that array, iterating through each row of data that was contained in the report. For every row, we create a new incident, or a request in this case, and we pass through the site ID for the site that was that particular row of the report. Once it's created the ticket, it just moves on to the next row of that report and creates another ticket if necessary. Then the runbook ends. That's the end of the scheduled process. Like I say, we just schedule that for once a week to check for groups of assets that need to be disposed, and we create a ticket for it. What takes over then is the workflow. So let's take a look at the workflow for the disposal ticket. So as soon as that ticket is created, we run this extra runbook, which links all of those assets to the ticket. So although we've created that ticket, we haven't actually linked any assets to it yet. That information wasn't in the report. We've just created a ticket that's linked to a site. So let's go back to the runbook to cover that. Link pre-disposal assets to ticket. And this is very similar to the previous one, really. What we do is we run a SQL query which returns all of the assets that are in the pre-disposal state, and we're filtering that by the site that's that the ticket has been logged for. So we're running a query against the asset API, and we're limiting the content that's returned by saying we're only returning assets that are in this site, where the status is 9, which is the pre-disposal state. And the response to that is an array of assets that meet that criteria. What we do then is link each of those returned assets to the ticket. Unfortunately for us, that list of assets, it comes through in an array which can be passed straight through to the ticket. So we don't have to do that array iterator for this case. We can just pass through that data directly. We can update the ticket, and all of those tickets, all of those assets are linked. What we do have to do for the approvers is build a HTML table that they can read through email or through the portal. And we do that by starting to build that HTML table manually. So this next job in the workflow, in the runbook, sorry, is to start putting in the header for that table. So we update the details HTML and we start creating that HTML table. You can see here we've got all of the headers for all of the data that's going to be stored in it. And we update the ticket with that information. We do nothing more than that. Then what we do is we iterate over that array that we received earlier. And we're going to iterate over each asset one by one. For each asset, we get the details of that asset because we need to populate that table. You may have noticed we don't have that information yet. So what we do here is we edit the asset because we are linking that asset to the disposal ticket. And one of the side effects of doing that is when that update is completed, the API returns all of the details of that asset. So we kind of combine two actions in one here. We're updating the asset details, but we're also getting the full set of data for that asset. What we do then is we return to the ticket and we do an update. Now this is a bit of a workaround because there is no get ticket action in here, but if we do a blank update, we're not changing anything on that ticket, but the API returns the current state of that ticket with all of the information that we need. And the reason we do that is because we want the current state of the details HTML. And we get that so we can append to it with the details of this asset that we've just got. So the next step is to update that ticket. We've just got it. We've got the details HTML, we've called it current state, we've stored that in a variable. And then we create a new row in that table and we start inserting the data from the asset that we've just got. So we update the ticket with that information. Then we end the iteration. If there's more rows, if there's more assets to add to that table, we loop back round. We get the details of that asset, we get the details of the ticket, and then we add another row with the details of the asset onto the ticket. Then finally, once that loop has finished, we've added all of the assets and created that table. We get the ticket one more time with the full table, and then we close that HTML table. So we just end the body of the table and the table element. That's all we do, and that's the end of that workflow, that runbook. If we go back to the workflow, after that happens, we begin the approval process. And as you probably saw on the diagram earlier, if it's rejected, it goes back through to the agents who can review the assets and make any appropriate changes to what's linked, and then they can restart that approval process. Once that ticket has been fully approved, then the we contractor is contacted directly. You've already seen behind the scenes, so I don't need to cover the recipe. But improvements wise, I feel it would be really useful to track the stale assets. So where you have a site that has never met the threshold of 50, you might have a set of equipment that's been sat in a storeroom waiting to be disposed for a reasonable amount of time. It would be great to be able to identify those in a report and automatically generate move requests that consolidated those items into sites where it would meet that threshold. The approval capability, now the current approvers have to approve en masse or not at all. It would be great to allow them to pick and choose which items they weren't happy with the disposal. Reporting dashboard, always, it would be great to use the data that's being generated to kind of reflect the disposal metrics and just show compliance with the policies that they have. And then, of course, integration with the finance processes, bringing in the depreciation information and that helps the approvers make those decisions. I absolutely love how those few tools, those essentially isolated pieces of configuration, have been combined into something that's really quite powerful. Now, Halo provides us with a really nice array of triggers that we can use to execute runbooks or update tickets. But this technique expands that palette vastly. It allows us to perform actions based on any data in SQL, including, as you've seen, aggregated data, so KPIs or metrics, anything that you want to define thresholds for. I'm sure this will have tickled a few people's brains, so I'd really love to hear what other ingenious uses people can come up with for the technique. That's all from me on this. I hope to be invited back next year, but in the meantime, please do get in touch if you have any questions or comments. Thank you.